If you guys have any questions and I haven't answered them in this video, please feel free to ask before the final. The final is Saturday, so make sure you ask. Number 1, compute each of the following derivatives. So this is derivative notation, or you could do y prime of t. Those mean exactly the same thing. So if you use to one and not the other, they mean the same thing. We want to find the derivative of y of t with respect to t. We have a couple of formulas that we're going to use. One of them is called the power rule, which says x, or some variable, it doesn't really matter, to the n, the derivative of x to the n with respect to x is equal to n x to the n minus 1. So we're going to use that formula. We're going to use the formula that says the derivative of a constant times a function is equal to the constant times the derivative of a function. And we're also going to use that the derivative of a constant, I'll just write constant, is equal to 0, that the derivative of f of, let's say f of x plus or minus g of x with respect to x is equal to the derivative of each one separately, plus or minus the derivative of g of x. So we'll call this number 1. We'll call this number 2, 3, 4. I want to find the derivative of y of t. The derivative of y of t with respect to t is equal to, the first thing I'm going to do is I'm going to use number 4, because I can separate those individually, right? I can say this is the derivative of 4t to the 5th with respect to t plus the derivative of t cubed minus the derivative of e squared with respect to t. Which one did I use? I used number 4, which just separated them all into different pieces. I don't really want to write the whole thing over again. The next thing I'm going to do is using 2, and I'm going to take that 4 in front of the derivative. So any constant you can take outside of the derivative, and then these stay the same. And now I'm going to use the power rule, which is number 1. So I have 4 times the derivative of t to the 5th. I have n is equal to 5. So it would be 5 times t to the 5 minus 1, or 4. And I'm going to do the same thing for the second one. We don't have to multiply it by anything because there's no coefficient. So it would just be n is 3 here. So it would be 3t to that 3 minus 1, or 2. And the last one is very tricky, because the one thing I didn't put up here, let me put that up here, is that the derivative of e to the x with respect to x is equal to e to the x. But e squared is different from e to the x. It is a constant, that's great. E to the x is not a constant because x can vary, but e is a number just like pi is a number. So if I take pi, I put it in my calculator and I square it, I'm always going to get the same answer because it's a constant. Why am I saying that? Because now I'm going to say that the derivative of constant is 0, and that is my final answer.
And so, and one more thing,
Yes.
for rule 1, n just comes down and then loses
Exactly.
from the exponent?
That's exactly what happens. So this
Okay.
is really 4 times 5. I guess I should write it like that. And then that would be 20. And that is the final answer. I would like to see some work. I don't want to just see the answer. Now I want to find the derivative of f of t. The derivative of f of t with respect to t. Well, I didn't write down here the sine, the derivative of the sine and the cosine. The derivative of the cosine. If I write it like this, that makes sense to everybody. That's negative omega sine of omega t. This is actually chain rule, which we're not teaching you, but you will definitely learn that in calculus. And this would be omega cosine of omega t. I want to take the derivative of 2 cosine of t. Well, remember, it's a constant, so I can take it outside of the derivative, and then I would just be looking for the derivative of cosine of t. And the derivative of cosine is negative sine. Omega there is 1. I don't have to worry about it. It's really negative sine of t minus, now 5 is that omega that I'm having to put in front. So it'd be 5 cosine of 5t. Now it's asking me for the derivative of f of 0, which means I want to say t equals 0. That's what df of 0 dt means. I have negative 2 times the sine of 0 minus 5 times the cosine of 5 times 0. And this whole thing, negative 2 times 0 is 0, so gone. And what's the cosine of 0? 1 times negative 5. So the answer is negative 5. We want to find the derivative of x of t. I'm just for shortcut purposes, I'm just going to write it like that. When you have to do some work, I usually put my work on, like I put a line down my paper and then I put work on one side so that when I do my derivatives, they go down and there's not work in the middle of it. You'll see what I mean, I think, in a minute. We have the product of 2 things multiplied to 2 functions, right? Because we have t times e to the 2t. That's actually multiplication. And then times 3, I'm not worried about my constant because I can just pull that out. But t e to the 2t, I do have to be concerned about because it is a product of 2 functions. I use the product rule, and the product rule says basically if I have f times g, and it probably says f of t or f of x times g of t or g of x or whatever, but I'm just going to leave off the of things. And I'm going to say this is f prime g plus the derivative of g times f. What I'm going to do is I'm going to say, well, let's let f equal t. And I'm going to let g equal e to the 2t. Oh, this one was also, this was, I don't know what they had here, omega. But if this is omega, then this stays omega and the omega comes out here. That means f prime is going to equal, well, t is the same as t to the 1 power. I can use my power rule. The n is 1, so I bring down the 1t to the 0 power. But what's anything to the 0 power? 1, so 1 times 1 is 1. So this is just equal to 1. And then the derivative of g is equal to, and that's why I put that omega in there, because we have to bring down that 2, e to the 2t. Okay, now the reason I do that thing where I put that all on one side is because now I can just fill in the blanks. I know that the derivative of x of t is f prime g plus g prime f. Now I just fill in what I have. F prime is 1 times g, which is e to the 2t, plus g prime, which is 2e to the 2t, times f, and f is t. I have e to the 2t plus 2t e to the 2t. Now, I could leave it like that. There's nothing wrong with that. That's a correct answer. I forgot the 3. And then that whole thing is times 3. This is 3 times this. This is, the whole thing is times 3. And this whole thing is times 3. And then I have this equals 3. And I have a factor in common, e to the 2t. And I'm going to factor that out. And I end up with 1 plus 2t. Now, why do I need to do that? You don't need to do that for the test. It's a good habit to get into because let's say I want to find a maximum or a minimum. Remember, I have to take the derivative and set it equal to 0. And I can use the rule that I use when I do quadratics, which is that if I have two things multiplied together that equals 0, it means A equals 0 or B equals 0. So now I could say A is 3e to the 2t, and I could say B is 1 plus 2t. And then I could set each one individually equal to 0. And it's a nice way to be able to find your zeros. Oh, why do we use the product rule?
Yeah.
Okay, because if you look here, do I have anywhere where it says TE to the AT? Or T squared or TQ, right? See what I'm saying?
You have e to the at, so go
I
ahead.
do. I have e to the AT, which is one function. And I have t to the n, where n is 1, as another function.
So it's a combination of those two
It's a
rules?
combination of those two functions.
Okay.
And I can't do either one by itself because those are multiplied together, right?
Yeah.
So because they're multiplied together, that's what product means. Product means multiplication. I have to use the product rule. You can see where my mouse is, right?
Yeah, I can.
I said, okay, well, let's make f equal to t, and let's make g equal to e to the 2t. And if I multiply those together, what do I get? Te to the 2t, right? Now I know it's a product. That's when I say, okay, so I need that formula. If you noticed, I said f prime, which is actually the derivative of f times g. I switched these. I'd actually do that for a reason. I switch them because there's something called a quotient rule, which you haven't learned yet. And the quotient rule is f prime g minus g prime f over g squared. I always remember it the same way for both. There's a minus for division and a plus for multiplication.